Okay, so chapter 5 goes into density and specific gravity. Let's get into some definitions. First of all, density is just a unit in which, unit is the gram of a substance, the weight mass of a substance per ml or volume of a substance, that same substance. So luckily for us, water is 1 gram per ml, and then that can apply to different densities for other substances as well. Specific gravity is ratio in which it's the weight of any substance to the weight of the equal volume of another substance. So let's just say there is a 200 ml of 200 ml of this weighs 96 grams. So it's 96 divided by, and then did I say 200? Whatever it was, 200 ml is equivalent to 200 grams of water because of 1-to-1 ratio, right? So 90 divided by 200. We'll go over into it. Okay, so questions for chapter 5. I said we weren't going to do much, but I have a couple here. Let's start with number 1. Pretty simple. 250 mLs of alcohol weighs 203 grams. What is its density? We said density was mass over volume. 203 over 250. Let's check it out. Divided by 250. 0.812. Okay. Well, that's grams per milliliter too, by the way. So it's easy peasy. And then I wanted to do number 3. Okay. 3 has some calculating in it. So let's get into that. 2 fluid ounces of glycerol weighs 74.1 grams. What is its specific gravity? All right, so what do we say? Gram of one substance over the weight of equal volume of another substance. So that other substance, by the way, is a standard. So for liquids, it's water. For gases, I think it's hydrogen. So we first need to, we can't do fluid ounces and convert it directly to water. We need to do mLs. So let's do that first. 2 fluid ounces, and it's expected for you to know these conversion, by the way, times 29.57 ml per ounce equals, I'm not gonna do that in my head, 957 times 2, 59.14 ml of glycerol. So specific gravity, let's just put SPGR. That's just R shortened, right? So mass of our first substance, 74.1 grams over. So our volume of glycerol is 59.14 milliliters. If we're converting it to mass of water, we have to multiply it by its density, right? So just think of conceptually. This is why we're doing this. 59.14 ml times 1 gram per ml equals same thing. That's why we get 59.14 grams of H2O. So don't do this, Dr. Dang, if you're listening to that, but if there were another substance and they give you the density of that as well, you would know to multiply by that density to get the grams of that other substance. So 59.14 grams of H2O. That's why we get that. So specific gravity, 74.1 divided by, what is that, 59.14. 59.14. 1.25. Let's do 1.253. So that's where we get specific gravity from. Cool beans? And it's just a ratio, remember that. There's no units, right, because it's a ratio. Cancels out this way too, by the way. All right. Next problem, number 5. If chloroform has a specific gravity of 1.476, what is its specific volume? So we talked about specific gravity. What is specific volume? It's, okay. Hard to put into words by itself, right? Okay, so we said grams of a substance over the equal weight of, or the weight of the equal volume of that same substance, right? That was what specific gravity was. So with specific volume, it's volume over substance over the volume of equal weight of that same substance. So let's just say 100 grams of alcohol is 200 ml, right? So 200 ml would be our top over 100 grams, right? So it'd be 100 grams of that would equal 100 mLs of water, 1-to-1 ratio. 200 ml of alcohol over 100 ml of water. It's the same idea as specific gravity, but just liquid now, volume. Cool thing about converting from specific gravity to specific volume is SPV, let's just say, equals 1 over specific gravity. It's inversely proportional. So bigger the specific gravity, the smaller the specific volume, and likewise. So let's see. To clear that, 1 divided by 1.476 equals 0.678, let's say, yeah. You want to do sig figs? We can do sig figs. 6775 or 0.678. Simple. That's more of a memorizing thing, right? But you also need to just remember that it's volume of one substance over the volume of equal weights of the standard, which in most cases would be water. Next question, 6. What is the weight in kilograms of 5 liters of sulfuric acid with a specific gravity of 1.84? Okay, so let me give you guys something that helps me usually with questions like these, for example, right? I draw this little pyramid looking thing, okay? It'll look like a pyramid eventually. Specific gravity is grams of a substance over equivalent of another substance. Most cases it's H2O, so I just put it as H2O. Why does that help so much? What are we asking for here? What is the weight in kilograms? Okay. What is the weight of our first substance with a given volume? So, because you need to remember conceptually, how do we get grams of H2O from the volume of our other substance. So if they give us liters of sulfuric acid, you know that's going to be that can be converted into grams of H2O as well. So, or ml of H2O. So that's why I put H2O by itself. It can be grams or ml exchangeably. So, and they have a specific gravity of 1.84. Now we come to why it's structured like this. If we're solving for this weight of our first substance, this times this. That's why it's next to each other. Specific gravity times H2O. If we're solving for a specific gravity, it's grams over H2O. Pretty cool, right? Or liquid of our other substance, grams over specific gravity. So it kind of, you still need to have that conceptual mindset, but like it helps in terms of visualizing it. Weight in kilograms of 5 liters of sulfuric acid, specific gravity. Okay, so let's do specific gravity, 1.84 times 5 liters. We usually go by ml, right? For our calculations for specific gravity and whatnot. Let's go by ml. 5 liters is 5,000 ml. That is, give it a second, times, whoops, times 5,000 equals 9,200. So 9,200 what? Grams. But that's not what they're looking for. What is its weight in kilograms? So 1 kilogram, 1,000 grams divided by 1,000, 9.2 kilograms. And that's correct. So use this to your own benefit. I feel like it helps. It's up to you if you want, if it helps you. And last question for this chapter. Calculate the volume in milliliters of 100 grams of each of the following. So they're giving us the, well, I guess the weight, right? The weight of each substance, and they're giving us a specific gravity. So let's draw that pyramid again. Probably shouldn't have deleted that or erased that. So 100 grams of each of the substances, and they're giving us the specific gravities. They're looking for the volume of each, right? Because, so grams divided by specific gravity, pretty easy, right? So for A, 100 divided by 0.96 equals, I'm just gonna write this out for the other ones too. 100 divided by 1.70 equals that, and 1.7 that. Could put, again, I'm not going by sig figs for these problems. 104.16 ml and 58.82 ml. Now you're like, oh, Sadipa, it says H2O. Why? But we're looking for the volume of the substances. We went from weight, the volume of that substance, to the equal volume of H2O to that weight of H2O. So it's that 1-to-1 ratio of water, you're able to exchange that. So that's why this does equal the the volume of castor oil and phosphoric acid. Capiche? Capuche. Okay, hopefully that's, eases some of the cracks of if there are any for you. That's chapter 5. We did skip chapter 4. I feel like that's more of just like memorizing and understanding abbreviations and then calculating from there. I'll go on to chapter 6, module A.